The term evolution is often thrown around, yet it's a broad topic that might need further definition. Did you know that the word evolution can be used for at least 6 different processes? In this video, we're following the line of thought on the origin of all things, beginning with the things we can see. In the world at present, we witness many variations occurring within different species. You see, animals adapt when they need to adjust to a change in their immediate environment, either physically or behaviorally. Even plants adjust to their climate and habitat. This type of effect the environment has on organisms is called epigenetics. These are variations easily observed in nature and have resulted in minor changes within a specific species of animal without altering the type of animal. This has sometimes been called microevolution. However, the true scientific name for variations within each species is genetic diversity. There have been many misconceptions about mutations. Random mutations cause deformities, diseases, syndromes, and even death, which are defects, not progress. Okay, so how do we have so many different kinds of animals? Charles Darwin's theory of evolution postulated that a single common ancestor evolved over millions of years while undergoing biological changes from natural selection. Those best suited to their environment survived to reproduce, and random mutations. This means that the first simplest cell evolved into a multicellular organism whose offspring gradually evolved into a fish-like creature, whose offspring then gradually started spending time above the water on land. These amphibians gradually left the water completely, becoming reptiles, which later evolved into birds, mammals, etc. This is often called macroevolution. It should be noted that scientists have not yet observed the change of one type of animal into another, not in nature or the laboratory. What about the origin of the very first life form? Darwin himself left the question of the origin of life alone. He acknowledged that science was not advanced enough during his lifetime to deal with the question and that he would probably not live to see it resolved. According to John N. Thompson and Michael B. Thompson, energy from the sun relentlessly bombarded the surface of the primitive Earth, and in time, millions of years, chemical and physical actions produced the first evidence of life. Formless, jelly-like blobs that could collect energy from the environment and produce more of their own kind. Scientific experiments today have still not been able to replicate the conversion from inorganic materials to organic structures. This process, known as abiogenesis, is a type of organic evolution. So where did Earth come from, and other planets and stars? Many scientists assert there were massive clouds of dust and gas in space, and gradually these gas and dust particles pulled together due to gravitational forces, forming groups which then condensed into stars. These stars converted hydrogen into other elements, which they ejected into space. These elements took the form of grains of dust within molecular clouds, which gathered into disks of swirling particles. Over time, these particles condensed to form other stars and also asteroids and planets. One problem with this hypothesis is that for the particles to gather together requires a gravity-like force, which can only be formed around an already established mass. According to Encyclopedia Britannica, because gravitation is a very weak force, however, its distinctive effects appear only when masses are extremely large. This process of how stars, planets, asteroids, etc. were formed is called stellar evolution. How did stars convert hydrogen and helium into the other elements? While stars are being formed, their cores are coalescing tighter and tighter together, which would squeeze and heat the hydrogen and helium. During this process, the fusion of the nuclei in the core releases nuclear energy and causes nucleosynthesis. Since then, the nuclear reactions in the life and death of stars have formed most of the other nuclei in the universe. Stars can create nuclei through 2 processes, either by combining 2 smaller nuclei, called fusion, or breaking a larger nucleus into multiple nuclei, called fission. Both ways result in new atoms. In the past, these processes also produced the elements on the periodic table that we know today. Nucleosynthesis within forming stars is highly theoretical and has not been observed or replicated. The process of hydrogen and helium evolving into all the elements on our periodic table is called chemical evolution. If the universe began with the Big Bang, what caused it? Andrew May, who holds a PhD in astrophysics from Manchester University, says, around 13.7 billion years ago, everything in the entire universe was condensed in an infinitesimally small singularity, a point of infinite denseness and heat. Suddenly, an explosive expansion began, ballooning our universe outwards faster than the speed of light. When cosmic inflation came to a sudden and still mysterious end, the more classic descriptions of the Big Bang took hold. What physics had been involved here? What forces were applied to this infinitesimally small singularity that caused it to expand? NASA describes cosmic inflation like this. The universe expanded faster than the speed of light for a fraction of a second, a period called cosmic inflation. Scientists aren't sure what came before inflation or what powered it. It looks as though there are still many mysteries concerning the Big Bang Theory. A name suited to the process of the universe's formation is cosmic evolution. A final question should have been, so where did this infinitesimally small singularity of infinite denseness and heat come from? Scientists can't answer this question yet. So, if you believe a small, heavy, and hot singularity is the ultimate cause of the universe, you definitely are taking a leap of faith. Thank you for watching. If you've enjoyed our video, don't forget to click the like and subscribe buttons below.